Hey everybody, welcome back. It's Mr. G again. Again, we're going to do another experiment from the Experiments in Basic Circuits Theory and Application from David M. Buchla. What we're going to be doing today is we're going to be doing lab number 11, which is Superposition Theorem. So there is a lecture that is also posted in this series on Superposition Theorem. This lab is quite short, at least the part that I'm going to be doing is quite short. Most of it is based on calculations and there are only a few measurements. So what we need is 3 resistors. We need a 4.7K ohm resistor, a 6.8K resistor, and a 10K resistor. And what we're going to do is we are going to build this circuit. Now, superposition theory is really quick. It's what happens in a circuit when there is more than one power supply connected. So if we're using more than one power supply, so in this case, there's a 5-volt power supply at one side, there is a 10-volt power supply at the other side. So 2 power supplies coming into the circuit, and how does that actually affect the circuit? So first thing we're going to be doing is we are going to be measuring each value of resistors and putting them in table 11-1. So the first one is the 4.7K ohm resistor. So the 4.7 kilo ohm resistor measures out to be 4.60K. Then the 6.8K, which is this one, it measures out to be 6.65K. Then we got the 10K resistor measuring out at 9.94K. So I'm going to build this circuit the way that it looks in the schematic so that it's easy to follow. So my 5-volt supply will be coming from this side and my 10-volt supply will be coming from this side. So what we've got is the first resistor is the 4.7K. So coming off of there like that, the 4.7K resistor. Oops, this one is the 4.7K. 4.7K resistor. So that's that one there, R1. Then we have our 10K resistor. That's going to go from that point down to here. I'm going to use one of these bus lines on the bottom as my negative common ground. And then off of this point here, I'm taking the other resistor. So that would be R2 is that 6.8. So I've got the R1 here, I've got the R2 here, and I've got R3 sitting here. This is my 5-volt supply. So my 5-volt supply is going to be coming from this side. And my 10-volt supply will be coming from the other side. So since we share the same grounding point for both power supplies, I will just use this point right here. And then my 10-volt supply will be connected here. So again, most of this lab is calculations on your part. So what we have are 2 values to be calculated here, one on step 4, one on step 7. I will do the measured values, you will do the calculated values. Step 5 is all calculation. Step 6 is all measured, some calculation and some measured. Step number 8 is calculation, and step number 9 is some measured values here and some calculated values there. Okay, and then step 10, again, we got some computed and some measured. So basically what I'm going to be doing is one measurement here, one here, 3 measurements, 3 measurements, 3 measurements. So we're going to start off at step number 4. So once we got the circuit built, you're going to actually do the calculation part. Okay, so you're going to do the calculation part and I'm going to do some measuring. So at step number 4, you're going to compute the total resistance RT as seen by the 5-volt source. You're going to remove the 5-volt source and measure the resistance between point A and B. So basically, what you're going to do is you're going to create a short circuit from C to D. So you're going to remove the 10-volt supply. So step 3 says remove the 10-volt supply, and we're going to short this out. So I'm going to remove the 10-volt supply and I'm going to short this out. Your job is to then calculate the total resistance looking at it from A to B. So coming at it from this side, what would be the total resistance? So then we're going to remove the source and measure the resistance between point A and B. So I'm going to remove the source. I'm going to measure the resistance, and this should match what your resistance value is on your calculation. So points A and B, approximately 8.6 kiloohms. So about 8.6 kiloohms is what our measurement value is, and that is our total looking this way. Okay, so that value on step number 4, right here, our total measured value is 8.6K. So now in step number 5, you're going to do again some more calculations. And then you're going to do some calculations here in step number 6. What I'm going to do is I'm going to measure the voltages that are present. So I'm going to remove my meter from this value. I'm going to reconnect the 5-volt source. And I'm going to measure the values of voltage. So you're going to do some calculations here. I'm going to measure the value of voltages here. So V1, so that's across R1, across R2, and across R3 with the 5 volts connected. So across R1, what I'm going to be getting is 2.66 volts. Across R2, 2.30 volts, and across R3, 2.3 volts. Okay, so again, R1 is 2.6, R2 is 2.3, R3 is 2.3. So those values go into the table here, here, and here, and you're going to compare them to your calculated values. Then, in step number 9, you're going to do the same thing, but we're going to be looking at it from the other supply. So, what we have to do is we're going to go back. I'm going to reconnect my original circuit. So there's the original circuit. So that's back here. Now what I'm going to do is I'm going to do this circuit. So I'm going to remove the 5-volt supply from this side. I'm going to put the jumper from A to B. again, you are going to, or I'm going to do a measurement of the resistance value, looking at it from this side. So I'm going to take off that power, look at my resistance. So my resistance, looking at it from the 10 volt supply point, I have 9.8K. So looking at it this way is 9.8K. So I've got that resistance. So that goes into the table here, 9.8K. Now we're going to move on to step number 9. Again, step number 9 is a bunch of your calculations. And for me, it's going to be measured values again across R1, R2, R3. But that is now with the 10 volt supply connected. So 10 volt supply is connected. I am going to do some voltage measurements. The voltage across R1 is, let me just click it on there, 3.2 volts. Across R2, 6.8 volts, and across R3, 3.2. Okay, again, R1, 3.2, R2, 6.8, and R3 is 3.2. So those values go into the table here, here, and here. Again, you've got some calculating to do. In step 10, you're going to do some calculations of the full circuit. So what we're going to do is we're going to go back to our original circuit. I'm going to connect my power supply here. Alright folks, so what we've got now is we've got both power supplies connected back up, so we're back to figure 11-1. And what we're going to be doing is we're going to be measuring the totals. Now what I'm going to do is I'm going to measure the voltage drops and just give you the magnitude. Your job as part of the computing part is to figure out the direction. So is it a positive voltage? Is it a negative voltage? I'm just going to give you the values as they sit as a magnitude without direction. You can see if you can figure out and see if which ones match your computed voltages and see if it all works out with the algebraic sum at the end. So here's what we're going to do. I'm just going to give you the magnitude of the voltages sitting across these resistors. R1 is 0.57 volts. R2, the magnitude of the voltage is 4.53 volts. And across R3, the magnitude is 5.54 volts. Okay? So just out of curiosity, if I go from here to here, this was my input voltage on this side of 10 volts. Input voltage on this side is 5 volts. Okay? So one more time, just the magnitudes alone, 0.57 volts, 4.53, and 5.53 volts. So those are the magnitudes for R1, R2, and R3. When you are calculating, following the directions, it will tell you as far as the magnitudes and directions of your currents, and therefore your magnitudes and directions of your voltages. My values are going to be magnitude only, and you have to figure out which ones match and how close they are. So that takes care of the measurement part for experiment number 11. And what's left for you is your calculations. So all the computed calculations here and here, as well as the computed calculations here. And you have evaluation and review questions. There are 6 of them for this lab. So that completes lab number 11. So hopefully that helps. And until next time, everybody be safe. Take care.